Hello, you're welcome to today's lesson. Today we want to look at what we call sets. SURDS. Now in class, we did real numbers in commas. And remember, said real numbers and by convention is represented by R. So under the real numbers, we have what we call rational numbers. Rational numbers represented by Q, and irrational numbers, which is usually represented by Q prime. So under the real numbers, we had rational as we have in this case, and we had irrational. I hope you remember them. Just as a recall, remember we said rational numbers, which is Q, can be said to be any number that can be expressed in the form A over B, that is in the fraction form, where b, which is the denominator, is not equal to 0. In effect, we are saying that any number that can be written in the fraction form, a over b, or in any fraction form, for example 2.5, is a terminating decimal, therefore is a rational number. We can have 2.33, and this is a recurring decimal with the 3 recurring, so it's a rational number. So you can have any number like this. This is also a rational number. So looking at this, 25.2525 is also a rational number because 25 is recurring. However, if you flip the coin, you pick a number like 2.11, 2.123, 5, 6, 7, 8, 9. This number is not having any recurring decimal, neither is it terminating. So this number that we have here is an irrational number. So what we are doing here is irrational numbers. Again, most numbers that are usually placed in a radical sign like this, √2, where the number under the radical sign is usually prime or odd, then usually this number becomes an irrational number. So usually if you pick your calculator and you punch the value of √2, it should give you a whole number and some decimals, which is neither terminating nor recurring. I hope this reviews rational and irrational numbers for you. Now let's go on to our main topic for the day. What we are dealing with is numbers that are placed under the radical sign like this. So we may have a number like √8, √10, √12, and these numbers are what we call sets. Now you can be asked to simplify these numbers. Now to simplify these numbers, usually, like I said earlier, the number should be in the simplest form, and by doing so, the radical sign must have a number which is usually a prime or an odd number under the radical sign. That not being conventional, what I mean by that is that to be able to simplify a set, then what we do is that we split the number or the number under the radical into multiples that consist of square numbers or perfect squares and a number which is not a perfect square. So to be able to simplify this fraction, this surd, we have root 8. To be able to simplify it, what we do is that we look for factors of 8. So the factors of 8 that we have, 1 multiplying 8 give us 8, then 2 will multiply 4. Now after listing the factors or knowing the factors, we go for factors that involves a square or a perfect square and a certain number. If you look critically, this number times this number will give us our root 8. So what we do is that we express root 8 into the form root 2 by root 4. And when that is done, you realize that what we have here is going to be a certain number that is odd or prime, and the second part having a square number. So this is the perfect square 4, and this is the prime number that is left. And so when you look at this, you realize that we cannot do anything about root 2. So root 2 will remain, and that will multiply the square root of 4. In this case, we take the positive aspect, which is 2. So in multiplying, what we do is that we treat this as a variable and treat this term as a constant. So the 2 will then become the coefficient of the variable. In that case, that will come to the front part. So we have our 2 multiplying our root what? 2. So this is the simplified form of our said root 8. So whenever you are given this, like I said, the first thing you do is that you express the number given to you into the product of two factors, where preferably one is a perfect square and the other can be any form. Right, so let's try the next example, which is root 10. So for root 10, if you look at it well, listing the factors of root 10, so we have 1 and 10, then 2 and 5. So 1 and 10, 2 and 5 being the factors of 10. Ideally, 1 by 10 will still give us root 10, still give us 10, then 2 by 5 will still give us 10. But none of these numbers here is a perfect square. So in that case, it means that root 10 is already in its simplest form, so we can't do anything about it. So that means that root 10 is already in the simplest form, so we cannot simplify it. Let's go back and check the last example. Good. The last example is root 12. So root 12. So for root 12, we have to list the factors of 12. So these ones you must have it off here. And what are the factors of 12? We have 1 and 12. We have 3 and 4. We have 2 and 6. So first, let's identify the perfect square in these factors. And the perfect square here is 4. And what times 4 will give us 12 is 3. So we express this as a product of root 3 and then by what? Root 4. So over here, if you pick your calculator, you can realize that the perfect square, we can find the root of the perfect square, which will give us 2 by this 3, which we cannot do anything about it because it's already in the simplest form. So if that's the case, what, like I said, we treat the one in the radical sign as a surd as a variable and treat this as a constant. So when you multiply a variable and a constant, preferably we bring the constant first, so 2 root the variable, which is 3. So this should be our simplified form of root 12. So for trial, I will expect you to simplify root 20. I'll expect you to simplify root 20, and then you simplify root 40, and I'll be expecting input from you. So the first one is and this is the second one, right? So this is the first part of the lesson. I'll see you again.